Okay guys, today we get to look at properties of logarithms and how to apply those properties. And there's three basic properties, and then we're going to write them all down today, and we're going to use one of them a lot today, and then we'll start using the other two in the next few days. Okay, and these are very important properties. We use them, you might use them in physics, you might use them in chem, we use them in calc. They're just three properties that you're going to need to remember about logarithms. And so once we write them down, then we're going to learn how to apply them. That's our learning target. But first we need to talk about what they are. So I just call them the properties of logs. Some people call them the log laws. So you have that double L there, but properties, oops, of logs. L-O-G-S. I was thinking laws. All right. Okay, so the three properties of logarithms are number one, called the product property. And what it says is you can have log base b of xy. So you're multiplying. That is the same as log base b of x plus log base b of y. These can go either way. If you want to make something smaller, you go from this side to x times y. If you want to spread it out to make it easier, it becomes an x plus y. The second rule is called the quotient rule, which says when you have log base b of x divided by y, that's the condensed form, that equals the same as log base b of x minus log base b of y. The third property of logs is called the power rule, and it looks like this. If you have log base b of x to the y power, that equals, you bring this power out front, y times log base b of x. And this one, we're going to use this one the most today, the power rule. It's a rule that you're going to use quite a bit. Actually, all these rules you use quite a bit, but the power rule is what we're going to focus on today. And we're going to try some problems. Let's try one like log base 4 of the fifth root of 64. Now that looks like something that we don't know how to solve when we first look at it, but we can do a lot of rewriting. This is log base 4 of 64 to the 1/5, because 1/5 is the same as the fifth root. So now I can use the power rule, and take this 1/5 and make it in front. 1/5 log base 4 of 64. So I have 1/5. Now another thing that you can do is this 64 we can change so that it has a base of 4, or you can just realize that you could rewrite this so it's 1/5 times 4 to some power equals 64. That power would be 3. So the answer to this whole thing right here is 3. So I have 1/5 times 3, which is 3/5. That's one way you could do that. The other way is if you say 1/5 log base 4 of 64, I can change 64 into 4 cubed, and then I can use the power rule again and bring that out front. So now I have 3/5 log base 4 of 4, and there's a special little log rule here. Log base 4 of 4 is 1, so 3/5 times 1 is 3/5. Log base 4 of 4 has to be 1 because 4 to the first is 4. It's one of those basic power logarithm rules. So let's look at another one. Let's look at natural log of e to the 9th plus 4 natural log of e cubed. Now here's my power rule. The 9 can come in front. So I get 9 natural log of e plus power rule again. There's a 4 already there, so I have to multiply. So I get 12 natural log of e. And the natural log of e is 1. Natural log of e is 1. So I have 9 plus 12, which is 21. There's the power rule. Let's try one more. Let's try log base 6 of the cube root of 36. So that's the same as log base 6 of 36 to the 1/3. So that's 1/3 log base 6 of 36. And if you're getting really good with logs, you can figure out that this has to be 2. So 1/3 times 2 is 2/3. All right. That's what you're going to do today. You're going to try problems where you have to use the power rule like I just did.